So everybody, thanks for joining us. I'm James Pagonis. I'm going to talk a little bit about asset intelligence and how to centralize your information and improve asset management efficiency. So a few things I want to talk about today. I'm going to talk a little bit about lessons learned in the various global markets. I'm going to talk about the importance of digitalization and centralized information around solar projects, as well as a little bit about what to look for when selecting digital tools. What I would like to do is get to know the audience a little bit more before we start this. If we can get the first poll question, that'd be wonderful. I just want to know where you guys come from, what do you do, so we get a better idea of the audience. So are you a project developer? Are you an asset manager? Are you an operations manager? Or are you a technology provider?
Let's give a few seconds. The poll is right now on your screen.
Okay, interesting. Well, it's good to see. It's good to see we got a broad range. I'm actually surprised we don't see any project developers with us tonight, but I can appreciate the early time or late time right now that it is. So let's talk a little bit about PowerHub and who we are. So PowerHub is an asset management platform for renewables. Hold on, I'm just. There we go. We are in about 18 different countries. We have 9 gigawatts of projects on the platform. We are a fairly large team for a focused asset management group. We are 45, included a dedicated team of customer success specialists who help our clients, and we do all of our own in-house development. Now, when I talk about asset management from our perspective, we see the asset as the entire facility, not just the equipment and things going on. We consider the asset all the things that come together to help a project make money. So the people, the processes, the financings, the regulatory components, the history, the documents. We see it as a whole package because all of it is what comes together to give the project value and make sure you have profits. A little bit about me. I'm James. I've been in the industry for 12 years, predominantly in solar. I was a developer and an asset manager for about 9 of those years. And over the last 3 and a bit, I have been using my experience to help develop the product here at PowerHub to help other asset managers manage their assets better. So I'm going to talk a little bit about lessons learned and best practices from other markets. These are personal experiences or things that we've seen that have come into PowerHub over the years and reasons why people reach out to us. So one of the first things that we've learned is that initial expectations were incredibly wrong. And this is always common. And it's not surprising. If we could predict the future, we wouldn't be working as hard. And the interesting thing about renewables is that for the first couple of years, it tends to keep up to what our expectations are. So we see initially that the things that people have saw to kind of trend there, but after that, it really seems to diverge from our initial plans, our initial ideas, our initial things. And regardless of where it was in the world, we see the same things occurring and occurring. And some of the things are things like your manufacturers go under and disappear. You know, regardless of how bankable they are, the size, the thing, they have disappeared in multiple different markets and they disappear. The second key thing we've learned is that the maintenance needed, both preventable and responsive, were much more than expected. So although they may have planned for certain things, over time, we find that much more expected things are needed on the plant. One that's very true to our hearts is that there's a lot more oversight and management from the non-technical components on these facilities. And when I say a lot more. I mean, some of these initial projects didn't even have a line item for it, whereas regulatory, financial compliance, environmental compliance, health and safety compliance have tended to take up a lot more time and require a lot more management, and as a result, tools to help manage that. And the other thing is that the oversight and the requirements have changed over time. We've seen it time and time again across markets that the regulatory processes change, the financing processes change. As the projects change hands, these differ and evolve. So all in all, things change. And the plans that are initially put in place fail. But that's not unique to solar. It's constant, it's consistent in business. But what we tend to find is those that have survived and done very well in this industry both understood that the plans would fail and change, but they've also understood their projects really well, and we're able to utilize these insights to adapt quickly and deal with these changes effectively. Well, the other consistent things we see and have learned across markets is that old systems don't scale well. We generally see one of two things in a market. Is one, they try and use the same systems in which they develop the projects with, or two, they try and use a top-down approach for renewables. And I'll talk about a little bit about both of them. Now, the initial one, which I spoke about, that they try and use the old systems, is what happens is as they develop, they've evolved into asset owners and asset managers. And they try to use the same tools like spreadsheets, Outlook calendars, CRMSs, and a couple homemade tool sets to try and manage these processes as they go. And all of these tend to fail for about the same reason. And that's that it involves people to keep managing these things and keeping them going and patching them together. And they're using these systems for an unintended process. And this is asset management. So as they keep growing and growing, get more complicated and complicated, these systems aren't able to deal with all the complexity and all the items that are out there. The other thing we see is that top-down approach. And this is where you have an organizational template come down and try and impose itself on all the projects. Now, this is typical for a place that wants to roll things up, manage at a very high level, and try and see information consistently across. The problem is that it doesn't fit with the nature of how renewables and solar tends to be developed. Because these projects are developed from the bottom up, they tend to have a lot of really unique characteristics. They have different financing structures, they have different regulatory structure, they have different agreements here and there. So when you try and impose a top-down structure on, they don't quite fit. And what you see is a lot of patchwork stuff going in, and again, a lot more people trying to manage this, manage these fixes they've put in place to try and cram the information into this process so that you can regulate at the top. And that essentially becomes one of the biggest liabilities in this. One is because you've got people at the heart of keeping these things working, and you want to keep them there for 20 years or more. And so what overall happens? What happens when you get people in systems, you get a lot of duplication. You get people putting information in various places, doing a lot of the same work over and over again. As well, because all this information resides in different places, you start losing context. So you can have generation in one place, you can have maintenance records over here, you can have weather reporting over here, and then you can have error logs somewhere else. So you don't have the context around what's actually going on and affecting the generation on your site. This, all in all, creates a rather large inefficiency. And your asset managers and operators are spending a lot more time trying to collect information, getting it together, just so they can try and figure out what's going on. Worse is when there's missing information. Human error without fail plays a huge part. And it's quite common that we run into portfolios with a lot of missing information over the years. This results in things like slow decision-making, as well as a lack of transparency, and makes it really hard to coordinate, especially for those asset managers who are trying to coordinate not only internally, but with external third parties. It becomes really hard to share information when you're not sure it's up to date, accurate, or even that you've got the whole picture. So with all that in mind, and now that I've scared you a little, what I'd like to hear from the audience is how many out there consider a portion of their business digital. And when I mean digital, I don't mean that they're using a spreadsheet or you're using, you know, a Dropbox account to store documents. What I mean is true digital processes. So if something comes in, it affects other things, people can come centralize. So is it 0 to 25, 25 to 50, 50 to 75, or 75 to 100?
Let's give it a few seconds to vote and comment on the results.
Okay. You know, this is not surprising at all. This is probably the most consistent answer we see, is there's a fair amount of people in the 25 or so range with portions of their process digital and a lot of their processes and systems still manual. I like to lead with a little quote here. When digital transformation is done right, it's like a caterpillar turning into a butterfly. But when done wrong, all you have is a really fast caterpillar. And I love this expression for two things. One, I think it's a win-win. And it tells me that even if you try to get digitalization and you get a faster process, you're still winning. But if it turns into a butterfly, you're really succeeding here. So let's talk about some of the importance of digitalization. Now, when it comes to digitalization, the real goals here are risk mitigation. Now, think about solar and renewable systems. There's not a lot you can do to generate more revenue out of them. It's really a game of trying to ensure that you're spending the least amount of money to ensure that you maintain the consistent output as expected. So risk mitigation is a key factor in this whole thing. So when you get to a digitalization process, the idea is minimizing the risk and getting to a more increased efficiency so you can reduce that downtime. So you can get the information to a centralized place so everybody can access it, get a whole picture, and make better decisions on that faster and quicker. And the other side effect of it is it tends to provide new opportunities to the teams that have a digitalization process. So they spend a lot less time gathering information, collecting information, or trying to hash out difficult decisions with not enough information. And they're spending more time trying to analyze information differently. They're chasing new opportunities. They're working on other markets, other opportunities, other projects. So with that in mind, how many of you are looking to start the digitalization process soon? And given that there's such a low number of digitalization right now, I'm kind of expecting this to be fairly high. So are you looking to see it in the next 3 months, 3 to 6, 6 months to a year more, or are you just not thinking about it at all?
Yeah, I think this is a very interesting question. Also taking into account the results of last one. So it will be interesting to see, yeah, what's the timeline, what is the eagerness to go in digital based on these benefits that we have been discussing. Let's give it still a few seconds. Okay.
I love that
Very
answer.
fast.
I'm excited to see that people are really looking to move and get a digitalization process in there. So I guess the next little chunk we're going to get into is digital tools and things to consider. Now, I see a lot of things, and I have some slight biases to which tools I like better, mine, of course, but what I do want to do is give some generic advice so when you're looking to digitalize tools that you're finding the right ones to help you solve the problems you want. Because the important thing is that you get a process and systems in place that work for you and your team. So the value of software. Now there's value of software at all sorts of different scales, whether you're doing 10 projects or 2 gigawatts of projects. It really varies based on the complexity. So what I mean by complexity is not just that you have a really complicated project. It's that that portfolio starts getting more and more complicated. You have different components, you have different systems, you have different equipment, you have different agreements, you have different styles of PPAs, you have different invoicing. As that complexity starts building, the value of digitalization increases exponentially, because having it in one place and having it all tied together makes it really easy to interact with that. As well as whether you're doing it early or late, you still have the scalability that's in there. Once you have digitalized processes, moving the next ones into it are a lot easier, and you have something that can scale easy with you, and you also have an idea of how quick and how big you can scale. Now, a couple tips on where to start here. One of the first things I see usually, and I see a lot of these, is I get this list from potential clients. They send this RFP out, and it's a spreadsheet typically with a ton of numbers on it and a bunch of information about what they want in the system. And this is great and all, but that's what it usually is wants. And I think that it's premature to create that list. And one of the most important things you should create first is a list of the problems you're trying to solve day to day. Dig into the things you're trying to do every day that you're trying to digitalize and trying to solve, and then rank them, right? It's much more important that you see what problem you're trying to solve and what value that software brings into it, because you could potentially get multiple software tools to solve the different problems, especially if they work well together. But the key is to make sure they're addressing your specific problems so that you have tools in place to deal with those. The next piece of advice is do some introspection. Look at what you have. Without fail, in order for you to get the most out of your software tool, you have to have the right information and data feeding into it. Make sure you know where that data is, make sure you know what you have before you make decisions on what you're going to try with it. It's like buying a saw and not having access to enough lumber to cut and build what you want to build. The last thing is to set a practical timeline. I see this clearly with you guys. Next 3 months, we want to get in there. The thing you have to evaluate is how much time you have to spend on this. One of the biggest limitations we find on our side to getting clients implemented is the time they have available to help the process. There is tons of decisions that a client has to make, as well as they know where the information is, and they need to dig it up and find that information and bring it into the system before it can be digitalized. So when you're thinking about doing this, think about contributing some of your time and how much time you can contribute over that period. And my piece of advice right now is do it now. Jump. There will never be a right time. Changing to a digitalization process will always be disruptive, but that's not a bad thing because it will always be disruptive. So it changes, it brings some things in. But if you get going sooner than later, you have the momentum, you have the excitement, and you're not waiting to play catch up. Because if your competitors put it in first and they're well ahead of you, you're going to be scrambling. And when you scramble, you're not going to be making any solid business decisions as you are right now, where you have time to think about this thing and put together a true process. My last piece that I always sort of say is let the software surprise you. All the software tools out there were designed by people who've looked into different types of problems and have a different perspective on problems. So let them come to your problems and show you different ways of tackling it. Because sometimes just bringing in a tool that can do it differently can actually change your process and save you a lot of time. And so let the software as well become part of your process, become part of your exploration on how to improve your own efficiencies and move yourself forward and get yourself digitalized. And thank you, everybody. That's about all the time I have. I'll be open for questions at the end. I do appreciate you all joining me this morning, this evening, this afternoon, depending on where you are. Thank you.
Thank you, James, for your insights. So indeed, we will be back to you for Q&As. Maybe we still have a time for one question before we continue. So you cited a few sources of inefficiencies. What would you say is the main source or the most time-consuming that people can save a lot of time with this digitalization of processes?
Getting information together. Without fail, I have seen most people spend an exceptional amount of time just trying to get all the information about something together to make decisions on problems. And in most cases, once all the information together, the decisions are quite simple and straightforward. It's just a matter of collecting that information so that you can make it. So when they're able to centralize the information in a single place, it is a huge value, especially if it can be shared amongst multiple groups within the same company, and avoiding potentially what we call information silos, where the information gets into one spot and isn't shared into the other parts of the organization that also needs that information.
Yeah, so indeed, real-time information is really key. So our next, let's get back to James in a bit. Our next speaker is Vishal Punamiya. He's CEO of Dronegrid. He has more than 13 years of experience, corporate experience, of managing regional and global IT organizations, having deployed innovative and market disruptive solutions. He's passionate about connecting new technologies to mainstream applications that address real business needs. Vishal, we will make you a presenter in a second, so please be prepared to take the grounds. Okay. Vishal, you can go on.
Perfect. Perfect. Thanks a lot, Marcel. I appreciate it. Marcel, can you hear me?
Yes, we can hear you well.
Perfect. Perfect. Okay, thank you. Well, I must just start by saying this is actually our first webinar since the start of our company, actually 2 years ago. So indeed, it is a very exciting evening or day, depending on where you are, for us. And we are looking forward to actually meeting many of you that might be attending either Solarplaza events in North America, Europe, or Asia over the next coming months and next year when the next San Francisco event will be held. So a little bit about the presentation today. You know, as the title suggested, we're going to be talking a little bit about you know, how aerial intelligence is disrupting asset management, particularly across multiple sectors or multiple phases across the life cycle of a certain site. And that's what we'll be exploring a lot in detail today. What we'll also be going into is asking the right questions, just you know, similar to James's presentation, where we talked about, you know, what are the key criteria to look for in choosing the right solution for your business needs. And finally, I will actually go into real case studies where we talk about different types of customers we've worked with over the last couple of years, and just hoping that you know, one of those case studies might actually relate to your specific scenarios. So before we jump into the presentation, I would like to start with a brief poll, just to get to understand my audience a bit better. So Marcel, if you could just help me with our first poll.
Yeah.
Thank you. So I would like to start just by understanding if you've tried aerial inspections on your sites over the last years. You know, I have an idea, you know, based on experience over the last 2 years, but would be interesting to just understand the audience a bit.
I think we're ready to show the results. Let's see, Vishal.
Perfect. Great.
Okay.
I think this is extremely promising. So you know, it allows me to literally jump straight into some of the technical aspects, and not you know, and expect people to just tag along with me. So so I am going to start by going on to Marcel. If you could, for some reason I can't seem to move to the next slide. There we go. Got it. So Dronegrid is an area, you know, we are a software company. We provide an end-to-end aerial data platform towards our customers. And we literally help our customers understand by gathering data, managing data, and analyzing data, either for a single site or multitude of sites that they may have across the world. So a little bit about the company. We are actually active in a few sectors. Okay, it is a little laggy, and I apologize for that. So we're actually active in multiple sectors. So starting with construction, mining, and energy. The reason I'm actually mentioning this at the moment is because you might be surprised how many best practices we have been able to bring in to the energy business from the construction industry. For example, the construction industry, like we are very heavily involved in road construction projects and commercial construction projects as well, where precision is extremely important. So, for example, a construction of a German Autobahn requires a very high precision in terms of GPS positioning. And this is where we are able to give our customers literally, although the requirements stated by the government may be 2 centimeters precision, we are able to give our customers up to between 3 and 6 millimeters in precision. And that's really important, and you will understand why during this presentation. From the mining sector, we're able to bring in our expertise from understanding and presenting topography, understanding geological facts that can have an impact on budgets during the surveying and the RFQ phases of solar or PV sites. And you will see that during the presentation as well. So those are some of the best practices, just to name a few, that we are able to bring into the energy sector, and vice versa as well. So from the energy sector, taking best practices and implementing it in the mining sector as well. So that's one of the reasons why we are active in multiple sectors and not just one. So if you go to the next slide, a little bit about the company. We provide, particularly for the PV industry, we are an aerial data platform where we have, we've really focused on developing an end-to-end solution for the industry, and that includes everything. So not just inspections and acceptance testing, but everything from surveying to engineering to construction monitoring, acceptance, and during the O&M phase. So you're literally talking about a 20-year, or depending on where you are, but typically a 20-year cycle for your site. We've inspected over 250 PV sites in 18 countries over the last 1 year. So that just shows how incredibly scalable we are, and also the growth that we've seen over the last year and a half. We work both with ground-mounted sites and roof-mounted sites. So as some of you that may be based in Europe, you may be aware that Europe has predominantly, especially Northern Europe, in Belgium where we are based, is predominantly roof-based commercial roof sites. Whereas if you go further south or towards the US or South America or even Africa, you will have a lot more ground-mounted sites. Our technology today is based on 4 verticals. So that's our flight automation software, image processing and analytics, and that combined with our network of local drone pilots. And that's what allows us to literally scale at a rate that few companies can scale. And it's the flight automation software as well that allows us to give our customers consistency. So no matter where you are in the world or where your site is in the world, whether it's in South Africa, whether it's in Chile, whether it's in Belgium or Japan for that matter, you will always get the same data consistency and image capturing quality thanks to our flight automation and image processing software. And you will see that in a bit where I will go into the technical details. So for instance, now here's where we talk about, what is a typical process like today in your industry, and I would like to compare it or in your company, and I would like to compare it how we do it. So we've actually reverse engineered everything. We work literally backwards to simply be put. We start with the outcome in mind. So for example, if it's a site acceptance, a site acceptance, let's say deliverable that you're interested in, our platform actually starts with the end product in mind. So you select your end product. You literally, let's say it could be a site acceptance or it could be progress monitoring. All of these things will do impact how the image acquisition will actually occur or how the operation is planned. And all of those things will actually have an impact on how the data is captured, how it's analyzed and processed, and ultimately how you work with that data. So all of these things are really important points that you should be expecting in any solution provider or a solution that you're looking at. So, so for instance, let's look at site surveying. Now, this is where we're bringing in our expertise from the mining sector, where one of the basic facts that customers or our customers question is, do I understand my site that we are looking at building or developing something, or developing a plant? Do I understand it? Do I understand the topography of it? How is the topography going to impact my cost? And am I working off accurate data? So those are some of the basic parameters that that one can use a real platform, and that's the starting point of the platform, to ultimately significantly reduce project risks and any budget overruns. We've heard this story over and again, where our customers tell us, I wish I knew that we were working on that particular site, and we ended up spending significantly more money in developing the property before even installation could begin, that they weren't aware of. So that's an example. The next part starts with the engineering phase. Now over here, I've used actually a roof-based site, because roof-based sites tend to be small, but also more resource intensive, particularly during the planning and the engineering phase. Because typically this involves sending a person on the roof, doing the measurements, or a surveyor on the roof, which is even more expensive to capture more precise data for large sites. Whereas with our solution, you know, literally the system automatically creates a CAD model from a point cloud, which you probably are all familiar with because you have worked with drones in the past. And this is really, really unique in the business, because today, even a point cloud is most products in the market today require a manual operation of creating a CAD model from the point cloud. And this is something that significantly increases the speed of execution, where you literally, if you're using a software like PVSys or Skeleton or Autodesk, all you have to focus on is creating or panelizing your CAD model, including even the surfaces are included, because surfaces of your roof will impact how you lay out your ballasts and the frames on your site. And so the ultimate win here is significant improvement in safety. That's one, because you're spending less time on the roof in measuring and planning the site. The second part is much faster layout planning, so that even during the RFQ phase, you know exactly what kind of cost you'd be looking at, and overall, you know, your execution periods are much faster. The next phase is a construction phase. Now, this is one area that we hear a lot, particularly in the Americas, where people want to understand, how is my construction site actually progressing? What is the level of completion versus, and what is the quality of the site versus the CAD model that was actually built? So being able to compare the CAD model versus the as-built model. And this is something where you literally on the platform, you're able to upload your CAD model, and based on the image data that's been captured and the CAD model, literally you're able to compare whether the panels are within tolerances, the angles, or also more importantly, if you have trackers on site, if the trackers are in sync across the site. Because these are the two most common areas we help our customers resolve very quickly using our data. So and also ultimately you want to be able to compare and communicate across multiple stakeholders on site. So for instance, if you are based in, let's say, the UK, but you're managing and building a site in Chile, you are really literally able to do that out of your office in London and monitor and control a site in Chile and communicate with on-site staff as well. The next one is the acceptance and maintenance phase. Now, this is where I want to spend a little bit more time to even talk about not just the automated anomalies detection and the acceptance testing, but also focus on the thermal image that you have in front of you. Now, most of you who have done some level of thermography, you will notice that there are absolutely no reflections on the entire site, on the entire image. Now, this is not a single image. This is actually an orthomosaic of multiple images that have been kind of stuck together. The reason you do not see any reflections or lens glares, independent of what time the site was flown, so this is something that is literally proprietary to us and to Dronegrid, is that for every pixel that is taken or captured, we literally are able to, we are taking the same pixel from 6 different positions while the drone is actually flying and continuing on its normal path. The reason we are able to do this is because literally our software behind it, the image processing software, automatically identifies a pixel with lens glare or reflections and replaces it with the same pixel but taken from a different angle. And this is what allows our platform to automatically remove lens glare while making sure that the data that's ultimately stitched together is distortion free. And that's what allows us to detect anomalies in a much higher accuracy and a much higher success rate than otherwise. So those are some of the key things to note. And also the most important is we do not normalize the temperature. So we literally are able to capture data, raw data at a pixel level up to 0.01 degrees Celsius in accuracy, okay? So, so over here you see a site with several string issues. So this is an acceptance testing for a site that was going live. And literally you see that there are several issues on the site that need to be fixed before the handover. The next one is some additional points to consider. Now, I won't go into too many details here. The first one is ease of use and how you deploy it. You want to make sure that especially if you're a multi-site owner across, whether it's in nationally or whether it's internationally, you want to make sure that you are able to deploy something that's consistently deployable across all your sites. There should be no exceptions. The second one is you want to make sure that the quality and the compliance side of it is taken care of as well, because ultimately you want to make sure that if there are warranty issues or disputes, what have you, you want to be able to comply with international standards. The third part is the ability to communicate and work with existing legacy or bespoke systems that you may have in place. That is critical. The ability to work with a wide range of assets. So for instance, we have customers literally that have anywhere from 50 to 60 kilowatts, all the way up to 200, 300 megawatts. In fact, we're doing a project at the moment, which is around a 500 megawatt site, which is currently being built. So you want a solution, you want to deploy a solution that's ultimately scalable across your entire portfolio. And finally, this is one of the key fundamental value propositions as well, which is you want to have the scalability from a network perspective. You want to be able to take advantage of the network. So in the screenshot there, you see actually one of our customers that's on our platform, where they have sites in multiple stages across the globe that are on our platform. The next one is some case studies. Now, here's a customer. We manage around 185 sites for them, primarily a roof-based sites, and you can pretty much judge that because they only have 150 megawatts of a portfolio, but it's actually spread across multiple roofs. Now, this is one of their sites where literally one of the key things, and I won't go into too much detail here, but I would be happy to take one-to-one calls and in the meetings on an analytics platform, where, for instance, customers are able to compare a certain type of an issue across their entire site or across their entire portfolio of sites to understand, is the problem happening at a manufacturer level, because they may be using a specific manufacturer for that particular site or that entire location, like nationally, and be able to understand why in this particular case you see the roof, but then on the right you see that this entire roof, around 70% of the site, wherever there are anomalies, are only bypass diodes. And that's an issue to that's a question to ask yourself, and perhaps to your procurement or even to the manufacturer, saying, what is it that's causing a multiple or a statistically significant issues of bypass substrings on the entire site? Okay, so that's an example that we helped our customer figure out, that they were indeed having problems with a particular manufacturer. The next one is, this is another customer of ours. They have around 3.5 gigawatt portfolio on a platform across 140 sites in 14 countries. So here's an example of a customer that has multiple ground-mounted sites, but fairly large portfolio size for each and every, fairly large size of a site as well. And here, for instance, here's an interesting issue. Where this is a site where you see on the left side where the system has identified PID issue on their, so they've also uploaded the string map of the site. But what's really funny about this particular site is that you have PID issues happening on the negative pole, but then on the other side you also see PID issues that seem to be occurring on the positive side of the string. Now, to be honest, we don't have an answer for this, of why this is happening, at least not because we weren't on the site to do the real checks. But what we actually help our customers ask the question is, why is that happening? Do we localize the issue for them? That's one. The second is to be able to ask their O&M partner or EPC the right questions, or the maintenance teams on site, or to go on site and check why these things, why these type of anomalies are occurring on their particular site. So it's about the ability to identify and ask the questions, at least as the first step, and then of course going to the real root cause analysis and fixing it at some point in time. So what it comes down to is automation. So we use AI and machine learning based methods, combining thermal and RGB data. So what that really boils down to is the ability for the system, our system is able to understand, is a certain anomaly caused by an external variable. That variable may be soiling, it could be shadowing, or it could actually be microcracks or PID issues or string issues or something at a module level, okay? And the ability to identify those differences makes a big difference, because it allows you to understand, are you going to refer that problem or that issue to your on-site team, to your manufacturer, or to another partner who might actually be able to help you with flash testing or doing electroluminescence testing or what have you. So those are the things that it allows you to literally localize and strategize on how you want to fix those issues. And finally, of course, it's online and it's completely digitized. So that allows you to, for instance, compare multiple vendors that you may be working with to the types of issues you see on your site, or even look at, okay, this particular module manufacturer seems to be having, we seem to be having more issues with them in Latin America, and that could be something to do with weather, it could be to do with your local partner that you may be using, or what have you. So it's about the ability to correlate different types of issues with certain potential root causes of that. Finally, it's interoperability, and that's the ability to work with multiple data sets, like, for instance, importing string maps, because importing string maps will give you a different perspective. It's the ability to work together in teams and collaborate on a single source of truth. And more importantly, to be literally able to compare different variables. And that's what it really comes down to, which is to give you better insights on your sites. So here's, I have a brief video that explains to you how easy it is to use our platform. Now, this is not our site. I've only used it simply because it is a site in Las Vegas, and of course everybody knows Las Vegas. So that was one of the reasons. So if you do recognize the site and it is your site, there is no other intention but just purely to show a site where in a location where people easily recognize it. So what's happening here is literally you go on a platform. When you have access to it, you select it on Google Earth. The system is automatically integrated into things like airspace clearance, high tension power lines for the entire world. So that allows us to notify our customers that indeed, if they have any exceptions they need to be aware of, they know it right there. Then what's happening in the background is the system sends a search query into our network of drone pilots who are in a 100-kilometer radius. The next thing that happens after that is based on their inventory that they have on the hardware that they have. It creates an automated flight path using assuming the sensors that they will be using. Then the next thing after that, the system automatically knows, okay, that's my flight path, that's going to be my altitude, those are my sensors that I'm going to use. That's the time I can fly based on all of those parameters. Then it knows how many battery swaps that would be required for that particular mission, the amount of time it would take, the driving distance for the pilot to go back and forth, the image processing time, and most of all, after all of those things are completed, it spits out a price for the inspection. So you can do this literally for any single site, every single site you own in your portfolio, anywhere in the world. For sites that for countries that we're not active in, we can literally go live. If you tell us about 2 weeks in advance, we can go live within a week, maximum 3 weeks. So this is how we are able to scale because we use off-the-shelf commercial hardware that's readily available anywhere in the world. Our pilots they literally download the app from iTunes App Store. Everything is calculated up front. They go on site and all they have to do is press start, and everything else is automated after that. So that's pretty much it from a presentation perspective. The purpose of my presentation today was to put an alternative out, to put some points to consider. And more importantly, if this is something that you indeed found interesting, I look forward to speaking to you and answering further questions and going into details. And yeah, Marcel, that was it from my side, and look forward to getting some more questions today.
Perfect. Thanks, Vishal, for your presentation, for the insightful presentation. Yeah, let's answer some of our questions for today. So and this is something we can start with you, Vishal, and this is something I would also like to ask to James. So in terms, you were saying that this solution might be applicable to plants from 200 kilowatts to 200 megawatts. So in terms of scalability, what are the different needs or requirements for such different size of PV plants?
Yeah, it's a very good question. So what we've seen from experience is the biggest limiting factor in completing let's say a small site to about 30 to 40 megawatts. That can be pretty much done in a minimum of let's say 20 minutes to around 2 days. Okay, and 2 days, I mean absolute flying time of the drone of around, let's say, 12 hours. Okay, if you go beyond that, the big constraints, especially depending on which part of the world you are, becomes the weather. So for example, if you're in Europe, you want to make sure that, for example, for instance, our platform does not allow the pilot to fly if the irradiance levels are below 600 watts per square meter. Okay, because then you start having issues with like false positives. You're not exactly IEC. You're kind of on the border with IEC compliance. So we literally, those are the biggest limiting factors. For sites that are above, let's say 40 megawatts, 50 megawatts, we tend to have 2 pilots actually flying, or 3 pilots actually flying 3 drones, or 3 drones flying on a site to make sure that we are able to capture the data within a maximum of, I would say, 3 to 4 days. So those are things that that we typically try to see from a constraints perspective and how we address it.
Perfect. Thanks, Vishal. I think it was a clear answer. We're just reaching the hour. I hope that the software doesn't kick us out. And I have the same question for James. Regarding digital asset management platforms, like in terms of scalability and different size of PV plants. What are the specific or the different needs or requirements?
So from an asset management platform perspective, the needs are varying. So what we find is on the smaller scale systems, they're a lot less about document management, information management, and just sheer volume of things, and they're not doing as much technical analysis, where they're more interested in making business decisions. So they're trying to figure out, how do I invoice this fast? How do I use a small team to manage these 200 different projects? How do I get some information really quickly in here? As well as, how do I make the decision on whether it's worthwhile to do things? Like, do I roll a truck? Is it worthwhile spending the $1,200 to roll a truck just to site to figure out the problem, or do I wait the time until the next maintenance happen? So those are the type of things we see more on the small side. On the larger side, we tend to find there's a lot more about collaboration, sharing information, bringing lots of information together and creating very complex reports that let them see different angles and different levels of data, as well as at the larger level, we have a lot more financial obligations, a lot more financial commitments. So the management of financial reporting tasks, regulatory tasks becomes a lot more of an important function that we do for them.
James, also something you mentioned in the presentation in terms of like a structured plan, let's say to go digital. In terms of the timeline that you mentioned, I mean, where to start? So what would you say to the attendees that mentioned that they are still not digital and would like to do so in the coming 3 months? What is an average timeline and where to start, really?
So it really comes down to size and time commitment to the amount of time to do it. I mean, we've seen and we've gotten fairly large portfolios on in 90 days, and then we've seen some take 9 months. And it really comes down to, the amount of time someone can put into the system, the amount of time someone can put into the process, how organized the data is and the information is, and how many different types of things they're trying to do, processes, systems, workflows. The more complex the implementation, the longer it will take, but the more value you'll get out of it. So you get what you put into it, all in all. But we can put systems up really quickly. We have ways of backdating information, getting a lot of historical records in very quickly. The main driver is actually setting everything up and getting it sorted and getting those processes in place.
Thanks, James. I have here a question for Vishal. So in terms of the COD, start of operations, when you do the mapping of the site, what are the most common built-in issues that you can identify with aerial inspection?
Yeah, so it very much depends. It's really funny that now that we've scanned in around 18, 19 countries over the last couple of years, we tend to see geographically we tend to see some issues more in certain geographies than others. So for instance, we, especially for new sites, as a general rule, we tend to see a lot of string issues. So for instance, particularly in developing or new, let's say, booming markets, where where people have just forgotten to literally wire strings or connect strings into the grid. So that's one type of an issue we see. Some of the crazy issues we've also seen are, now some people may find this surprising, we don't, where panels have been damaged even before they were installed, or it's literally been installed, let's say last week, and for some reason they're already damaged. We've seen crazy things like footprints, like shoe prints on modules as well. So those are the types of issues we see most of the time, especially on new sites. You don't tend to see module like failures or something, but mostly on new sites we see string issues. And then of course, as the older the site gets, you start seeing more things like PIDs, bypass substrings, snail trails, stuff like that.
Mm-hmm. And
Yeah.
how long would take, if we take a round number, how long would it take to map a 1 megawatt plant?
A 1 megawatt plant, fairly fast. So 1 megawatt plant is around, on average, now I'm using certain assumptions. You're looking at around 1.5 hectares. So assuming or around multiple, I think for the North American colleagues, around 3 acres, I would say close to 3 acres. So you're looking at literally less than an hour
Mm-hmm.
of everything. Yes.
Yeah, that's quite impressive and indeed very very time saving.
Yeah.
So just we need to round off the webinar. Maybe one last question for James. So in terms of in terms of growing portfolios and even bigger amounts of data, so how can technology and what are the trends that you see to help accelerate the process of growing a healthy portfolio?
So a lot of the things we've seen about growing a healthy portfolio is about setting up consistent processes. And I don't mean that again, we're not using that top-down approach, but setting up processes in order to drive to questions. So gathering information across multiple CMMSs that are being used in different things and recalibrating it into PowerHub as a single ticket structure so you can look at apples to apples within us. We also do some translation between other types of forms and information and get them into a similar style so that people can look at them across their whole portfolio. So all of this translational and transitional data, bringing it into one place so that people can see it in the same way across their portfolio is one of those huge value adds on when portfolio gets large and allows them to build processes that are much more structured and deal with the problems at hand.
James, Vishal, thank you again. We will now round off the webinar. So here are in the screen, you can see my contact details and the details of my colleague, Saori Minamino, that is dedicated to solar asset management Asia. If you have any questions regarding the webinar or the conference, please get in touch with us. I would like to thank everybody for their input and participation. I hope the webinar was valuable. Remember that we are publishing the recordings soon enough, so you will be able to see this information again, the contact details of the speakers today. So yeah, me, James, and Vishal, we hope to see you at the conference in Tokyo or at any of our upcoming conferences, either in Milan, in Singapore, in Mexico, quite a global range. I wish you a great day or a great evening, depending on where you're based, and look forward to meet you in Tokyo in May. Thank you.